Today's video I would like to introduce a very nice problem of Bulgarian Mathematics Olympiad edition 1968. Here is the following information. Find all possible values of k such that we have this equation system. We have x1 plus x2 and all the way down to the xk equals 9. So, and also the second equation is indicated the inverses of these numbers. We have the inverse of x1 plus the inverse of x2 and all the way down to the xk as an inverse equals 1. Okay, so this one have a solution in positive numbers. So the question find these solutions. Okay, so in fact this is very straightforward problem. It doesn't need any higher technique or the tricks, just very simple. Before we get started, just I would recommend to give the try to this problem prior to getting into the solution. So when we come back to see the full solution, now let's go ahead and jump into the solution. So before I start solving this one, I would remind you about a very important and useful theorem. Is called AMG theorem, arithmetic mean value geometry theorem. You have k term from x1 through xk. So I'm going to do the same thing here. So I will have x1 plus x2 and all the way down to xk is superior or equal to we have k term is multiplied by n kth root x1 and all the way down to the xk. This is the product to the 1 over k as a root, okay, as an exponent. This term is very clear, equals number 9 as we have here. So on the other hand, we have this expression. It will be written on the same form by applying the AMG theorem on the second equation. So I will have 1 over x1 plus 1 over x2 and all the way down to the 1 over xk is superior or equal to k term is multiplied by kth root of the inverses of these numbers. 1 over x1 is multiplied by 1 over x2 and all the way down to the 1 over xk to the 1 over k. Okay, this one is also equals to 1 as a given information. Okay, I'm going to raise kth power on the second equation on both sides to see what's given us. If I'm going to do that, I'm going to put it here. I will have number 1 here is superior or equal to k to the k. This exponent will be cancelled out because we have 1 over k as an exponent. It was raised to the k as an exponent. It will be cancelled with k here. So this one is multiplied by the 1 over x1 and all the way down to the xk. Okay, now this term I'm going to multiply both sides by this product x1 through xk. So I will have x1 is multiplied by x2 and all the way down to the xk is superior or equal to k to the k. Okay, so the next thing that I'm going to do now, I'm going to raise both sides to the 1 over k as an exponent. So we'll get here x1 is multiplied by x2 and all the way down to the xk is raised to the 1 over k as an exponent is superior or equal to k, because this exponent is arithmetically cancelled down to number 1, because when we raised the k as a power on both sides, so this one is cancelled out to the number 1. Okay, that's what happened here. So now if you take a look at both expressions, this one is the same as this one, but this one it needs to be multiplied by k. So I'm going to multiply both sides by k in order to get to this same one that I have here. Okay, so if I'm going to do that, I'm going to multiply this one by k and k on both sides. I will have k squared on the other side. So now I'm going to make the comparison. I'm going to bring this one down here. So I will have this term, which is 9, is superior or equal to this one. K is multiplied by x1 and is multiplied by x2 and all the way down to the xk to the 1 over k. This term is the same as this term. This one is superior or equal to k squared. So as we know, k as a positive integer, also k is strictly superior than 0. because when we raise to the k as an exponent, k must be different than 0. K is always strictly superior than 0. So here I'm going to take the square root on both sides as a k as a positive integer. So we'll get 3 is superior or equal to k. So I get to this result. Okay. So in the other word, k is inferior or equal to 3. Now we will have the following numbers. The k is taking the following numbers. K you will take. I'm going to put this one in order. So k starts from 1, 1, 2, and 3. That's the values of k can take. Now I'm going to go through each one. If k equals 3, I'm going to start with a big one, okay, and come down. If I'm going to replace k with number 3, I will have 3 terms here because k is dependent on the number of terms. So if I'm going to do that, this one is giving me x1 plus x2 plus x3. So I will be ended this one, whatever the terms are, you will have the sum of 9. So for the second equation, I will have the inverse of these numbers. I will have 1 over x1 plus 1 over x2 plus 1 over x3. The total of these numbers equals 1. Okay. Since the sum of terms is given as number 1, that means x1, x2, x3 is always strictly superior than 1. If one of these numbers was strictly inferior than 1, we wouldn't have number 1 here because this one it would be bigger. Because if you have these numbers smaller than 1, okay, so this one is telling us x1 and x2 and x3 and all the way down to xk, okay, is always superior 1, especially for these 3 terms. Okay, this one, whatever is, this one is telling us, so the only way to write this form 3 consecutive terms to get these results, if you have x1 equal x2 equal x3 equals number 3, because 3 plus 3 plus 3 is giving us 9. For this one, the inverse of 1 over 3 plus 1 over 3 plus 1 over 3 is giving us 1. Now let's move on to the next case when we have k equals 2. Okay, k equals 2, I will have 2 terms here only. x1 plus x2 equals 9 is the same number. Okay, so for the second equation, I will have the inverse of this one, 1 over x1 plus 1 over x2 equals number 1. So it's very clear here. Now we have limited terms here. Now simply we are going to solve this one by using both equations. So I'm going to combine these 2 equations in order to find x1 and x2. Okay, so I'm going to find x2 and insert it into the second equation by moving over x2 to the other side. So I will get x2 is giving us 9 minus x1. When I'm going to multiply side by side, I will get x2 plus x1 in numerator. Then I will have this product x1, x2 in denominator. By multiplying side by side by x1, x2 is giving us x1 plus x2 is giving us the product of x1 is multiplied by x2. It's very simple. I'm going to take this value of x2 and insert it into the second equation. So I will have x2, I will have x1 plus this term plus 9 minus x1 equals x1 is multiplied by 9 minus x1. Okay, so this x1 will be cancelled out because one is positive, the other one is negative. So we'll have number 9 here equals 9x1 minus x1 square. Okay, so by moving over the terms, I will get the form quadratic equation. I will have x1 square minus 9x1 plus 9 equals 0. Now I'm going to solve this equation as I'm calculating delta. Delta is giving us 9 square, which is area 1, minus 4 times 9. So we'll have area 1 minus 36. I will get delta equals 45. So the solution is x1 is giving us minus 9, which is 9, plus square root of delta, square root of 45, which is 9 is multiplied by 5. By taking 3 outside of the square root, I will get 3 is multiplied by square root of 5. We'll have 3 square root of 5 divided by 2. So the second solution, I will get 9 minus 3 square root of 5 over 2. This is the only solutions that I found. I found two solutions when we have k equals 2. Okay, when we have k equals 1, we don't have no solution, because here I will have one term only. I will have here x1 equals 9. When you take the inverse of 9, is giving us 1 over 9, which is impossible, because we need this term to be number 1. Okay, so if you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.